do some recording while I do it. Okay. So homework 1 was very simple. It just gave you two classes. So women who smoked during pregnancy and women who did not smoke during pregnancy. And this is the weights of their babies in grams. And it's very simple. It just asks you, make a bar graph of the arithmetic means for the two groups and add error bars and summarize what you see. So let's go ahead and do that. So where is my JMP? Uh-oh. Okay, so we'll open JMP. Very simple. And then the first thing to do is, of course, to put the data into some table. So in some questions, you will already have the data in like a CSV file, and you just have to load it. In this case, I did not give you the CSV file, so you have to manually type or copy all 20 of these values in. So you can do, for example, like new data table, or however you want to do it, and you would just type the values in here, like 2120, 310, 2120, 310, 3010, etc. And these are both people who smoked during pregnancy. Oops. Oh, sorry. Smoked during pregnancy. So they are, I'm just making like a correspondence. So smoked, I'm naming this column. So this column is going to tell whether the person smoked or not. So yes, yes. And this column tells the weight of the baby in grams, right? And then I would just fill in all the values, right? From the, so the 10 would be yeses, and then the next 10 would be nos. I already did this, so I'm not going to type it all again. So here is how it looks when you finished, right? You have 10 values that are yeses, and then the 10 values that are that are nos, just by typing in these numbers here, right? And then we just have to make a bar graph with 2 bars. So to do that, there's different ways to do it. The easiest way is just the graph builder. There's like a link there too. And then it will basically give you your columns over here, and you can tell how you want to make the graph in this space. So smoked is what we want here. You can make a horizontal bar graph too if you want. I'm making a vertical one. So I put the data, so smoked is in the X, so it's gonna do, and because it's a category, it's actually making 2. If you left it as a numeric value, it might get confused, especially if you used like 0 and 1 or something. And then birth weight is over here. And right now it's just showing me each dot represents the birth weight of the baby, right? This is actually, a good representation of the data if there's small amounts of data, but I want to make the graph a bar graph. So I'm gonna select over here. And so it draws the bars. So the smoked yes and no. So it looks like the default is, you see, it's the summary statistic is the mean. So in other words, how high the bar is just taking the average of each of those categories values. So 10 categories for the left, 10 categories for the right. And then we want to put some error bars here. So we see the error interval here is standard deviation. That's what it says in the standard deviation. So we add standard deviation, and then this is sort of our result. So now we want to sort of save this, so we can say, like, there's like a button up here, done, and then it gives us this graph. This graph is still like a JMP graph. So if we save this file, it will make will save like some computer code that says how to make this graph. We don't want that. For our homework, we want to put this as a picture, right? So we can do different ways. We can just say like save here, and you can select. So right now it's like this JRP, which is something, I don't know. We could select like different formats though. So like, for example, PNG file is like a type of image. We can give it a different name. Homework 1, number 1. Just give it a name. And then so it made this this graph and saved it as a PNG file. You can save it as a JPEG. You can save it as a PDF. You can save it however format you want. Because we're going to put it in a document file afterwards for the homework, right? So that's problem number 1. So I'm just going to go ahead and, I don't know, wait, where was that saved? It was saved in here. I don't have Word in here. Great. I'm just going to keep all these together so I know where they are. Home stats 2025, homework 1. So I'll move that picture in there, and then we can do number 2, and then just put the homework together all together at once. Where's JMP? JMP. So that's homework. That's problem 1. Problem 2 is get the Titanic data, and then plot the age of the passenger versus whether they survived or not. And plot 2 quartile box plots of the variable age in years. There's different ways to do this, and then briefly explain your findings. There's different ways to do this. I'm just going to show you how to do it using the graph builder because it's the same as problem number 1. You could have also extracted if you had like a summary of the quartile plots too. So first of all, you download the data, so it saves it as a CSV file from this link. I assume you know how to download the link. It should automatically download it. So I'll just assume that you have it, and we will open that file. So from JMP, we can say open. We can find our Titanic data that we downloaded somewhere. Titanic data, here we go. So Titanic data, if you just open it, it basically correctly reads it since it's a CSV file, so it's very easy to read. The one thing you have to make sure of is, of course, to change the types of the columns that you need. So for in this case, P class, which is the class of the passenger. We don't care about that today. We want survived. So this should be a category, right? 1 means survived, 0 means didn't. But it automatically thinks it's a number, which is not correct. So we're going to change it to a category, nominal, right? A nominal category to make sure that it knows that. And then the other one is what? Age, which it should automatically know is a number. So it's correct. So then we're going to do graph builder again. Make a graph. And we want to plot whether they survived on the bottom against their age. And so the raw data looks like this, right? Each dot represents a person. This is the people who didn't survive. They had this age. Like a lot of the people were like 22 years old. A lot of the people were like 30 years old or something. So but we want a distribution that is a box and whisker plot, a quartile plot. There should be an option up here. This one, it looks like what we want. So you can click on the box and quartile plot, and this is basically what we want. Did I tell any other thing here? 2 quartile box plot. Yeah, it doesn't tell you specifically. So of course there's other things you can set over here, like the, quantile. So this shows the 25th, 50th, 25th, 60th, whatever numbers. We just want, this one's fine. So this shows the 50% and then the 25 and 75%, and then the outlier, which is, remember, the interquartile range times 1 point something. And then these dots here are like extremes that are outside of there. So that's pretty much it for this homework. We want to save this, so we can click done, and then we can save it as a PNG file. So down here we can save as type. Of course, if you're on a Mac or whatever, it might be different based on a little bit different looking, but the idea is there's something that will tell you an option to save as a different format. I'm going to save as the PNG file, and I'm going to name it, stats 2025 homework 1 number 2. Save it in a folder that's easy to find. Yeah, so that looks good. So that's both of the sort of the contents for homework number 1. And then, of course, we need to, write the homework, which is to make a file sort of report for the homework. Of course, this will depend on what sort of software you use to make a document. If you know like LaTeX, you could use that. I'm just going to use like sort of Microsoft Word equivalent. I don't have Microsoft Word, so I'll use LibreOffice, which is like a free version of it. So I will put it. Whoops. Okay. So, stats 2025, homework 1, your name, your ID, and then, problem 1. And you can you can write the problem here again or not. It's okay, you don't need to. I want to insert the image. So there's different ways to do this based on, of course, what software you use. Usually it's like some sort of insert type thing. I'm going to go find the files I just made. This one doesn't, you want to make it big enough. And then, of course, so this one's like I said, there's no specific, correct answer for this one. Just like maybe the people, the plot shows the means and standard deviations of birth weights of babies of women who smoked during pregnancy or not. It seems maybe the smoked group has slightly higher mean, but I don't know, but there's overlap of the standard deviations, and so it is difficult to tell. You can write sort of whatever you want. I mean, you should be able to tell that this is a little bit higher, but I mean, there's no sort of correct answer to this one. The main thing was to get you used to putting data in and then like making a graph, right? And then we can do problem 2. Problem 2. And again, so you could do it on a different page, same page. It doesn't really matter here. I'll find the image for the second one. Oops. So this plot shows the, I don't know, oops, distribution of ages for those who survived the Titanic disaster and those who did not. Oh, it's not. I don't know. I mean, I don't know. I don't think there's any difference between these. We can run, of course, a test, like a chi-squared test, to see if there's a difference. Actually, not a chi. We can run a like a t-test to see if there's a difference between them. I didn't teach you how to do t-tests yet, so it's just the purpose is, again, just to practice loading the data, setting the columns correctly to the format, and then, you know, plotting what you want to plot. Seem to be much difference in the means or the medians, I guess, the medians or the distribution of ages, although those who did not survive seem slightly older, right? Because this is 0 is not survived. Maybe these are a little bit higher, although it's like, you know, really hard to tell. You'd have to run, you know, you could calculate those actual means in JMP. It would tell you those means. There's maybe a few more outliers here. I don't know, further analysis would be necessary to determine if there is a statistical difference. I don't know, something like that. In this case, like I said, what you write doesn't really matter. I wrote quite a lot. You didn't even have to write this much. Just like, you know, say like, okay, they seem about the same. Would have been fine for homework number 1. Okay, so that is homework number 1. You want to, of course, save your homework wherever. Stats 2025, you know, homework 1. You could put like your name, Veal example. Right, so I'm saving it as a, but if you save it, it will save it as like a document file, like a .doc, or in this case it's .odt, open document format. For the homeworks, you have to submit as a PDF file. Please submit as a PDF file because it opens directly in Panda when I grade it, so it's very easy to grade. Instead of having to download a document file, open it, you know, things get moved around in the document file. Like if I move this here, like it moves it, it's really annoying. So PDF file, it locks it in place as like a sort of, you know, format, so you can export. There's different ways to do it. You know, export as a PDF in Microsoft Word. Also, there's like option to export or show or something like that, or save. You can say like export as a PDF, and it will make a PDF file for you and ask you where to save it. Whoops, wrong place to save it, but it doesn't matter. Yeah, and then it makes a PDF file for you. This is not beautifully formatted, but it doesn't really matter. I mean, I really don't care so much for these, for the homeworks, as long as, you know, it's not, you know, mixed up and I can't tell what's happening. So that's homework number 1, very simple. Oops. Homework number 2, of course, requires a little bit more because you have to do the statistics. So let's quickly do homework number 2. Homework number 2. Homework number 2 was about the chi-squared tests. So again, 2 problems. So it's about the polio vaccine. Gives you the total sample size and the number of cases. And it says do a chi-squared test and, you know, give an answer whether there was an interaction. Yeah, this is an example. Okay, so then let's do JMP again. Open JMP, not the Titanic data. In this case, again, I did not give you like a CSV file, so you have to type the data in yourself. In this case, it's very easy because there's only, you know, 4 numbers to type in. So we can do a new table. So it's the so I'm going to make group. So in order to sort of encode this as a contingency table, I have to make 3 columns. One that represents the group. So are they a polio vaccine, a placebo or a vaccine? One that represents the other variable, which is did they get polio or not? So polio, yes or no. And then the third column is going to be the number of people in that group. Right? So there's going to be 4 rows, 1 for each possible combination of the two categories, and then the third one's going to tell the number of people in there. So I should say not group here. I should say vaccine group. And then I don't know, got polio. Also, it's going to be a category, so a nominal group, and then the number of people in that group. You can name it, number, count, whatever. So vaccine group is placebo, and vaccine. You can name these whatever you want, of course, right? These are just categories. They just have to be different for the two groups. Otherwise, it won't be able to tell the difference. Got polio is, yes, no, yes, no. So that's all 4 possibilities for the 4 contingency table things, right? Placebo, yes, placebo, no. Vaccine, yes, vaccine, no. So that's all 4 possibilities. And then we have to tell how many people are in each group. So there's actually a different way to do this. I'm going to just calculate the number in each group. So I directly tell you the number of polio cases, 108 in the placebo group and 34 in the vaccine group. So 108 people got polio in the placebo group, and 34 got polio in the vaccine group, right? So placebo group, 108 people got it. Vaccine got 34 got it. The other number is the total number, sample size. So how many people are in the placebo group? So there is, we could type no. So for the placebo group, the number of people who did not get polio will be the total number of people minus the people who got polio. So it's going to be this number, 201,002 minus 108. I'm just going to 201,002 minus 108. You can do it by hand, use Google, whatever. This is the number 200,894. Oops. So 200,894. And this is going to be the people who are in the vaccine group and did not get polio. So this is going to be 200,671, right? No, 269. 669. 200,669. Is that right? 20703 minus 34. Yeah. Okay, and then this is your table. And then from this, we want to do a chi-squared test. So the way that you do that is with the, fit y by x. You can also click the, button. There's different shortcuts, but we want to fit y by x. We want to run a predictive, analysis, and we're going to predict whether they got polio, the response from the vaccine group. Since chi-squared is symmetric, so it actually doesn't matter which one you put where. When we do t-tests or we do regressions, it will matter the order. But in this case, it's the same to predict polio from vaccine group or to predict vaccine group from polio. And then we have to put the count of people in the frequency, because if it was just raw data, like it had each person was separate, like polio group, yes, got, yes. If we did so if we had 40,000 rows, then that would be fine. But in this case, we just have sort of the summary. So we have to tell that this column represents the number of people in that group. So I have to put the number column or the count in this frequency column. You click OK. It already knows its category by category, so it's going to give you the chi-squared result down here. This Pearson's chi-squared, 38.467, and the probability, the p-value is very, very small. So then what you can do is you can save this. You can either just take a screenshot of it if you want. You can just report it. You can just copy the values in your, you can write them by hand if you want, but it's easier if you just you can save this as a picture to reference when you're running your test, because it gives you both the contingency table and the results. It also says 2 by 2 observed and expected. Is there expected here? No, so you can add the expected over here. And then we want to, so this like little red arrow, it tells like, what cells to show. I don't want these. And then we can like save this as a screenshot. Is that gonna work? On screen, can print screen work? So you can either use like, this type of thing and, oops. You either like, use a print screen type thing and just like select, the part that you want. It's not as good because it's not saved as, it's just like a picture. That's one way to do it though. And you could directly put it in, let's make a new document. Stats 2025, homework 2, trivial, blah, 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 blah. We can put our sort of results in here. Just keep it for when we're going to write it. The other thing you can do is you can actually export this all as a file using export. Yeah. So we want to like export this report, and you can click file, export, or I guess publish works too. No, export. And you can say like as text, as an image, as a PDF, as HTML. I'm going to choose PDF. You could also choose image. And I'm going to save it as, stats 2025, homework 2, 1, chi-squared. And it gives me some options for, the format of the PDF file. Just like yes. And so now it made this as a PDF file. And then you can, import it or copy it. Oh, that's kind of ugly, huh? It's probably better to do it as an image then. But that's another way to get it. You can either screenshot it or you can actually export it and export it as a PDF file or an image file. And then you can include it in your document file. So that's problem number 1. I should show you how to write it. So that's our contingency table. Problem 1. So we tested the interaction between polio vaccine group and placebo group. Between polio vaccine group, placebo group, and the outcome of getting polio or not. A chi-squared test, so we can say like 1 df chi-squared and then chi-squared equals 38.467, p less than 0.0001. So the df is here, right? It's the df, number of degrees of freedom. And for all 2 by 2 contingency table, it's always going to be 1 degree of freedom. It just shows a significant interaction between the groups. Between the variables. Effective in reducing polio rate, or something like this, right? So that's sort of the type of thing you should write. You could just write this piece. That's problem 1. Problem 2. sorry, I'll save this temporarily. Stats 2025 homework 2 Veal example. Problem 2, basically the same thing. Use the Titanic data, and then does the passenger being in first class have an influence on survival? So we'll make a chi-squared test and do the result. Again, contingency table, expected values, and test statistic. So the important thing here was that you were able to correctly, you were able to correctly identify like these numbers, right? And like I guess the 1DF. You were able to pick out from here what you need. So in this case, it's the chi-square ratio is here, and the p-value is here. So problem 2, we're basically doing the same thing. Load the Titanic data. Let's go back to JMP. Oops, I guess I can save this. Homework 2, 2025, homework 2, problem 1, polio table. So let's load the Titanic data. And we want to do a chi-squared test of first class versus survival. So of course, survived, we need to make sure it's in the right format again. If you already saved it as a JMP table, then it probably will save your change. In this case, I'm opening it from the CSV again, so it didn't change it. So I'm going to change it to back to a category, right? The other thing is we need to make p-class, we need to basically make a new column, a new variable that represents if they're first class or not. So right now, p-class is 1, 2, or 3 for if they're in first class, second class, or third class, like their ticket, were they in like, the expensive class or the coach class, or like the poor class in the basement of the ship. So we need to make a new class. So to do that, I give you a hint here for how to create a new column and use a formula. And then we want to make basically p class is 1 will be true and everything else will be false. So let's go back to here. So I'm going to make a new column. Did this freeze? Oh, okay. Named first, like is first class. Doesn't really matter what you name it. It's going to be numeric. We can set it afterwards to a different thing. And then I'm going to make it from a formula. So you can select like column properties from a formula. I think you can also just say from formula. Yeah, formula. And then like you can sort of write your formula over here. So to do that, I'm going to put p class here. And it's going to be p class equals 1. So what this means is basically equals is the computer language for, is the same as. It's not two equal signs, because if you just put 1 equals, it's usually assignment. In other words, you're telling it, make p class equal to 1. We want to compare. Compare, is p class 1 or not? You could also flip it around and say p class is not equal 1. And then true would represent second and third class, and false would represent first class. But we're going to do equals. That's finished. Apply. And so now you see over here, our new column, it should be 1 wherever the p class is 1, and it should be 0 wherever it's not. 0 representing like false. So 2 is false, and 3 is also false. So it looks like it worked. I'm going to name this column, is first class. Okay. And I can make it into can I make it into a category? Does that work? Yeah. And then, so now I have my two columns. So I'm going to do the analysis, fit y by x. Same thing. We're going to do a chi-squared. So we're going to predict p class. Oops. We're going to predict is first class by p class. Uh-oh, this is saying it's a continuous number. y by x. I don't know why it's doing that. Anyways, we're going to predict is first class, sorry, not P class, it's survived from, survived and is first class. We're going to compare them. Since this is the raw data, we don't have to put a weight, right? That's only if we're making the contingency table, by ourselves. In this case, it's the actual data, so we just compare these two variables. Okay. It gives us the contingency table, the chi-squared and everything, etc. We can also, we want to again add the expected values here. Remove these numbers. So this is our contingency table, our expected values. Again, I can, take just a screenshot of this. Is the easiest for me. Or you can click, export as an image, for example, homework stats 2025, homework 2 to results. So it, export it as an image for me. You could do it either way. So I'll put my result here. And here we can say, I'll do it on the next page. So we can look again here. Our Pearson R is 102.222. So it seems there's a significant effect of the, so a 1DF chi-squared analysis shows a significant interaction between passenger being in first class and their survival. So chi-squared df equals 1 equals, the statistic is 102.22 and the p is less than 0.0001. Yeah, and I mean, honestly, that's all that we need for, of course, you can write more if you want to analyze it more. And then this whole thing here, we want to save it, export it as a PDF file again for submitting it on Panda. And then this, then you would submit this on Panda. Okay, any questions about that? So that's the first two homeworks. I'll post these results, and I guess I think I just recorded me doing this in case you want to check it. I'll post that video. I'll put it on YouTube or something, and you can confirm afterwards. So you should do this for the third homework too, the same type of thing for your homeworks. Of course, you don't have to copy the thing from JMP. You can make the contingency table manually and just copy the values if you want, but it's just easier if you're doing it in JMP to just copy it and paste it in the homework. You don't have to, as long as you include the required numbers, but it's just easier to do. Okay.